Hello everyone, welcome back to my channel. My name is Sandeep Raturi and today's video is going to be very exciting for you. In this video, I will cover all types of time intelligence DAX functions which are crucial for both interview preparation and your daily Power BI tasks. As of now, there are 33 types of time intelligence DAX functions and we will discuss all of them in today's session. So make sure to watch the video till the end, and if you find it helpful, don't forget to leave a comment. Before we dive into the functions, I want to discuss two important things. The first is the calendar table. When working with time intelligence DAX functions, you often need a calendar table, especially when your main data set has missing dates. For example, in this data set, we don't have sales data for March 2nd, 4th and 5th. If you are calculating a running total, functions like TOTALMTD, DATESMTD may not work correctly in such cases. That's why a calendar table is essential. It ensures all dates are present in a continuous sequence, allowing time intelligence functions to perform accurate calculations. In one of my previous videos, I explained in detail how to create a calendar table. You can check that out for a better understanding. Now let's create a calendar table. Go to the modeling tab and select new table. And after that you have to write this DAX code. So here we used calendar DAX function, and calendar DAX function support two argument, start date and end date. So in start date we passed minimum order date from the orders dataset, and in end date we passed maximum order date. And after that you have to click on commit and it will generate the date like this. So in our data set, minimum year was 2012 and max year was 2015. So it generates the date from 1st of January 2012 until 31st December 2015. And you can see that the calendar table contains all dates in a continuous sequence without any missing values. Next, we will establish a relationship between the calendar table and the orders table to ensure proper functionality of time intelligence functions. So as you can see that I created a relationship between orders and calendar tables based on order date from the orders dataset and date column from the calendar table. The second important point is about quarters. Keep this in mind as it will help us understand how time intelligence DAX functions work at the quarter level. In quarter 1, we have Jan, Feb, March months. First month of quarter 1 is January and last month of quarter 1 is March. In quarter 2, we have April, May, June months. First month of quarter 2 is April and last month of quarter 2 is June. In quarter 3, we have July, August and September months. First month of quarter 3 is July and last month of quarter 3 is September. In quarter 4, we have October, November and December months. First month of quarter 4 is October and last month of quarter 4 is December. So let's start from opening and closing balance DAX functions. We have 6 types of opening and closing DAX functions such as opening balance month, quarter or year, and same for closing balance month, quarter or year. See the definition of opening and closing balance DAX functions. In Power BI, opening balance and closing balance DAX functions are used for financial and inventory analysis to calculate the balance at the beginning or end of a specific time period, such as month, quarter or year. Now let me show you the DAX function for opening balance month. So as you can see that this is a DAX code to calculate the opening balance month. So here we used opening balance month DAX function and it supposed to argument. In first argument we pass the sum of sales and in second argument we pass the date column name which is coming from orders dataset, and after that click on commit. Now we will use that DAX function in the table visual. So in this table visual, as you can see that we have 3 columns: order date, sum of sales, and this is the opening balance month measure. And here as you can see that for the January month it is showing blank values. Reason behind, for January 2012 there is no prior balance from the previous month. which is why the result is blank for the January. For February 2012, the balance at the beginning of the month is taken from January 31st, 2012, which is 7642.59. Same you can check for the February 2012, because for the February month, prior balance from the previous month would be January, and in January it will consider the last sales date, which is 31st January 2012. So that's the reason it is showing 7642.59. Same if you will check for the March month. So for the March 2012, the balance at the beginning of the month is taken from February 29th, 2012, which is 12,565.77. Same you can see here, because for the March 2012, prior balance from the previous month would be February, and in February it will consider the last date of the sales, which is 29th February 2012, and sales is 12,565.77. So that's the reason you can see here opening balance month for the March would be 12,565.77, which is coming from last date of the February 29, 2012. Now let's understand the opening balance quarter. Definition would be the same. Calculate the balance at the beginning of a specific quarter based on the given date column. In opening balance, we consider beginning of a specific time period, and for the closing balance, we consider end of the specific time period. Now, let me show you the DAX code for the opening balance quarter. Here you can see the DAX code for the opening balance quarter. We only change the DAX measure name, opening balance quarter, and in first argument we pass the sum of sales. In second argument we pass the order date column. And now we will use this measure in the table visual, and you can see that this is the result of opening balance quarter. For the first quarter, April to March, it is showing blank result. Reason behind, for the quarter January to March, there is no prior balance from the previous quarter, which is why the result is blank for this period. And if we talk about second quarter, April to June, you can see here it is showing 2582.80 balance. Reason behind, for the April to June quarter, the balance at the beginning of the quarter is taken from the March 31st. You can see here. So for the March 31st, 2012, sales is 2582.80. So that's the reason it is showing the same sales for the second quarter. And for the first quarter, last month would be the March 2012, and in March 2012, last date is 31st March 2012. Here you can see the sales, and same sales would be the opening balance for the second quarter. In same way, you can check the opening balance quarter for other quarters. Now let's understand opening balance year. So let me show you the measure for the same. So here you can see the DAX code for the opening balance year. Everything is same. I only change the DAX function name, and in first argument we pass the sum of sales, and in second argument we pass the date column name, and after that click on commit. And now we will use same DAX code in the table visual. So this is the opening balance year result, and for the first year 2012, as you can see that it is showing blank result. Reason behind, there is no prior balance from the previous year. So that's the reason for the year 2012 it is showing the blank values. And for the year 2013, as you can see here, it is showing 7740.66, which is coming from previous year 2012 last date sale. So if you see here, for the year 2013, prior balance from the previous year would be 2012, and from 2012 it will consider the last sales date, which is 30th 12 2012, and sales is 7740.66. So same sale you can see here for the 2013 opening balance year. And if you check the same for year 2014, so you can see here it is showing 10,688.58, and this is the prior balance from the previous year, which is 2013, and in 2013 it will consider the last sales date, which is 31st December 2013, and sales is 10,668.58. Same sales would be the opening balance year for the year 2014. I hope you got some clarity how opening balance month, quarter and year works. Now let's talk about closing balance DAX functions. Definition would be the same. The only difference between opening balance and closing balance DAX functions are: opening balance calculate the balance at the beginning of a specific time period such as month, quarter or year, and closing balance calculate the balance at the end of a specific time period such as month, quarter or year. Apart from that, syntax and DAX code would be the same. We will only change the DAX function name. Now let me show you the code for the closing balance month, quarter or year. So this is the DAX code for the closing balance month. As you can see that here I only change the DAX function name, closing balance month, and apart from that everything is same. So in first argument sum of sales, and in second argument I pass the date column name. This is the code for the closing balance quarter. So everything is same. Closing balance quarter is the function name, in first argument sum of sales, and in second argument date column name. And this is the DAX code for the closing balance year. So here I change the DAX function name closing balance year, in first argument sum of the sales, and in second argument I pass the date column name. So you will create three DAX function, one for the closing balance month, second for the closing balance quarter, and third for the closing balance year. And after that we will use these all three DAX functions in the table visual. So first we will use closing balance month, then closing balance quarter, and last one is closing balance year. So let's understand the result for the closing balance month. As per the definition, it calculates the balance at the end of a specific time period. So here we are talking about month. So for the January month, end of the sales is 31st January 2012, which is 7,642.59. So that's the reason closing balance month for the January is 7,642.59. And if we check the same for February month, so February end date sale is 29th February 2012, which is 12,565.77. So you can see for the February month closing balance is 12,565.77. Same you can check for the March. So for the March month, end sale is on 31st March 2012, which is 2,582.80. So you can see here for the March month it is showing 2,582.80 closing balance month. Now let's understand the closing balance quarter result. So for the first quarter, closing balance would be the 31st March 2012 sale. So if you see here, first quarter ends on 31st March. So let's check the sales for the 31st March 2012. So as you can see here, this is the 31st March 2012 and sales is 2,582.80. So that's the reason for the first quarter it is showing the same sales 2,582.80. So that would be the closing balance for the first quarter. And for the second quarter, so second quarter starts from April to June. So for the second quarter, closing balance month would be the June last date. So let's check the June month last date. So as you can see that, so for the second quarter, last month would be the June, and in the June month, last month sales is on 30th June 2012, which is 3,844.66. So that's the reason for the second quarter closing balance would be 3,844.66. So in same way you can check the closing balance quarter for the other quarters. Now understand the closing balance year. So for the year 2012, closing balance would be 31st December 2012 because year ends on December. So let's check the sales for the 31st December 2012. So here you can see that in the December month we have only sales until 30th December 2012. So we will consider this day's sale for the closing balance year for the year 2012. So you can see here it is 7740.66. So you can see here for the entire year 2012, this would be the closing balance year sale. And for the year 2013, again closing balance would be the 31st December 2013. So let's check the 31st December 2013 sale. So as you can see that in the year 2013 we have 31st December 2013 sale, which is 10,668.58. So for the entire year 2013, closing balance year would be the 10,668.58. So in same way you can check for the other years as well. So I hope you got some clarity how closing balance month, quarter or year works. Now let's understand another time intelligence DAX functions, first non-blank and last non-blank. Here you can see the definitions for both. The first non-blank and last non-blank DAX functions is used to return the first and last value in the column for which the expression has a non-blank value. Means first non-blank DAX function will return the first value in the column for which the expression has a non-blank value, and last non-blank DAX function will return the last value in the column for which the expression has a non-blank value. Now let's understand this definition with practical. So this is the data set for first non-blank and last non-blank. So here we have four columns: date, sales, year and month. And now we will create the measure for first non-blank. So before that we will create one common measure, total sales. So this is the measure name total sales, and here we are calculating the sum of sales. Later on we will use this measure inside the first non-blank and last non-blank DAX functions. Now we will create another measure for the first non-blank. So this is the measure name FNB underscore date, and first non-blank DAX function support two argument. In first argument we pass the date column name which is coming from sales dataset, and in second argument we pass the total sales measure name. And now click on commit. After that add one card visual in the report page, and we will drag FNB underscore date measure into that card visual. And you can see here it is showing 5th January 2018, because if you notice in the first non-blank first argument we pass the date column because we want to see the first non-blank date as per the sales. So if you look into the data set for the 1st December 2017 there is no sales, and for the 5th January 2018 we have 14,000 sales. Means as per the definition of first non-blank, it will return the first value in the column for which the expression has non-blank value. So we are looking for the date where sales is not blank. So this is our first non-blank date as per the sales. So I hope you got why it is showing the 5th January 2018. And now let's understand how it works. In the backend, Power BI sorts the data based on the specified column ascending order. So here we specified the sales date column. So in backend, Power BI will sort the date ascending to descending order, and then it will return the first non-blank date. So here you can see the date is in ascending to descending order, and for the 5th January 2018 sales is 14,000. So means this is the first non-blank date as per the sales. Now let's change the scenario. Instead of date we will pass the month column name. So for that we created another measure FNB underscore month, and here we pass the DAX function name first non-blank. In first argument we pass the month column name, and in second argument we pass the total sales measure name. After that we added one more card visual and we drag that measure into that card visual, and you can see here it is showing February. But if we look into month column, it should be written the January, because January month has first non-blank sale. 4th December month, if you look here, there is no sale, and 4th January month we have 14,000 sale, so it should be written the January. But as I mentioned earlier, Power BI sort the data based on the column we specify. So here you can see, since we pass the month column, Power BI sort the data alphabetically by month name and then returns the first non-blank value, which is February. So here, if you sort the month column name, then you will get the actual clarity. So now Power BI sort the month name alphabetically. So December comes first, then February, and in February month we have first non-blank sale, which is 13,000. So that's the reason it is returning the Feb. So I hope you understand how first non-blank DAX function works. Now let's understand the last non-blank. So everything would be the same, logic would be the same. The only difference, last non-blank DAX function will return the last value in the column for which the expression has a non-blank value. So here you can see data set is the same. We have date, sales, year and month. Now let's add one card visual in the report page, and here we created LNB underscore date measure for the last non-blank. In first argument we pass the date column name, and in second argument we pass the total sales measure. Now let's add this measure into the card visual, and it is returning 6 March 2020. So now let's understand why it returns 6 March 2020 date. If you look into the DAX code, so we are using last non-blank, so it will check the sales date column where sales has non-blank value, but it will check from the last. So in backend, first Power BI will sort the date column from ascending to descending, and then it will check from the last. So if you look into the date column, so this date column is in ascending to descending order, and in last if you see, we have date 6 March 2020 where sales is not blank. So that's the reason it is returning the 6 March 2020. Now let's change the scenario. So instead of date column, we will pass the month column name, and DAX function name would be the same, last non-blank. In first argument we pass the month name, in second argument we pass the total sales measure name. And if you look at the month column, which is already in sorted order, and from the last, if we check the March month as non-blank sale, so that's the reason it returns the March. In the first non-blank DAX function, we will look the first non-blank sale, and in the last non-blank DAX function, we will look the last non-blank sale. In both cases, in the backend, Power BI will sort the specified column data ascending to descending order, then it will return the result. So I hope you got the clarity how first non-blank and last non-blank DAX function works. Let's understand another time intelligence DAX functions, which are next day, next month, next quarter and next year. So as name suggests, it will returns the next day, month, quarter and year values. So you can see here I have one table visual where I have two columns, date and sales, and later on I created next day, next month, next quarter and next year measures. Now let me show you the code for the all next day, month, quarter and year measures. So this is the code for the to calculate the next day sales. So here I used calculate DAX function, and inside calculate DAX function, in first argument I used sum DAX function to calculate the sum of sales, and in second argument I used next day DAX function, and inside that DAX function I used calendar table date column. And here you can see that I already created relationship between orders and calendar table based on order date from the orders table. and date column from the calendar table. So this is the DAX code, and after that click on the commit. In same way I created next month sales DAX measure. Everything would be the same. Calculate, inside calculate sum of sales, and in the second argument I pass the next month function name, and then I pass the calendar date column. Why I am using calendar date column here? Because as I told you earlier, in the calendar table we have date in continuous form, or we can say in continuous sequence. So that means in calendar table there is no chance to miss the date. And whenever you used time intelligence DAX function, so most of the times calendar table is required, because sometimes in our main data set some dates might be missing, or we may have sales only for a few dates instead of the entire month, quarter or year. And if you are dealing with time intelligence DAX functions, so to perform the time intelligence DAX function perfectly, we need date in continuous sequence. So that's the reason I'm using calendar date column here. And now let me show you the code for the next quarter sales. So again code is same, I only change the DAX function name here, next quarter, and apart from that everything is same. And this is the code for the next year sales. Calculate sum of sales. Here I only change the DAX function name next year, and then calendar date column name. After that add one table visual in the report, and if you notice here I used calendar date column here, then I added sales column here to compare the sales with DAX measures result, and after that I added 4 measures here. Now let's understand the result of next day, next month, next quarter and next year DAX measures. So for the 1st January 2012 you can see the sales 808.56. So this is the next day sales result. So means it will return the next day sales, which is 314.22. So same sales you can see here, 314.22. For the 2nd January sales is 314.22, and you can see the next day sales 4503.54, which is this. So as you can see here it is returning the next day sales. Now understand the next month sales result. So if you see here, so for the January it is showing 1,03,717.92, and if you look into the second visual, for the February we have total sales 1,03,717.92. So as name suggests, next month sales. So for the January, what would be the next month sales? So next month sales would be the February sales. So that's the reason for the entire January month it is showing the same sales, which is February sales 1,03,717.92. And if you check the same for February month, so in February month next month sales is 1,35,746.40. and if you check here for the March, total sales is 1,35,746.40. so for the February month, next month sale would be March sale. So that's the reason it is showing 1,35,746.40. So in same way you can check the other month's sales as well. Now check for the next quarter sales, and if you look here for the second quarter, total sales is 4,80,132.84. so here as name suggests, next quarter sales. So from January to April it will show you the 4,80,132.84, because this is the next quarter sales, which is quarter 2, 4,80,132.84. For the first quarter it will return the second quarter sales, and for the second quarter it will return the third quarter sales. So it will work like that. Now let's understand the result for next year sales. So if you notice here, for year 2012 this is the sales, and for year 2013 this is the sales 26,77,438.69. so that's the reason for the year 2012 it will return the 2013 total sales, which is 26,77,438.69. And for the year 2013, it will return the next year sale, which is 2014 total sales. So in this way, you can check the result for the next year sales. So it is very easy. Everything would be the same. Only we will change the function name. So here we use next day. So for the next month, we will use the next month. For the next quarter, we will use the next quarter. And for the next year, we will use the next year DAX function. Apart from that, everything will be the same. So I hope you got some clarity how next day, next month, next quarter and next year DAX functions works. Now let's understand another time intelligence DAX function: previous day, previous month, previous quarter and previous year. As name suggests, they will return the previous day, previous month, previous quarter and previous year sales for the given date column. Now let me show you the DAX code for the same. So this is the DAX code for the previous day. Here I used calculate DAX function, and inside calculate DAX function you can see the two arguments. In first argument I used sum DAX function to calculate the sum of sales. You can see here. In second argument I used previous day DAX function, and inside that DAX function I used calendar date column. As I already told you, why I am using calendar date column here instead of our main dataset date column. Reason behind, most of the time intelligence DAX functions required calendar date, because in calendar date we have date in continuous sequence. Sometimes in our main dataset some dates might be missing, or we may have sales only for a few dates instead of the entire month, quarter or year. So that's the reason time intelligence DAX function required calendar date so that they work properly. Now let me show you the DAX code for previous month. So here you can see everything is same. Here I only changed the DAX function name previous month. And this is the DAX code for the previous quarter. Again I only changed the DAX function name previous quarter here. And this is the last DAX measure previous year. Everything is same, calculate sum of sales and then previous year and calendar date column. After that, add one table visual in the report page, and here I used calendar date column. Then I use sales column, which is coming from our orders dataset, and then I added all four DAX measures here: previous day, previous month, previous quarter and year. Now let's understand the previous day measure result. So as you can see that for the 1st January sales is 808.56, and for the 2nd January sales is 314.22, and here you can see the previous day result for the 2nd January. It is showing 808.56. So for the 2nd January, 1st January would be the previous day, and here you can see the 1st January sales is 808.56. So that's the reason for the 2nd January it is showing 808.56 previous day sale. For the 3rd January, 2nd January would be the previous day, and here you can see the 2nd January sales 314.22. So that's the reason it is showing 314.22. For the 4th January, previous day sales would be 3rd January, and here you can see the 3rd January sales 4,503.54. So here you can see the 4th January previous day sales is 4,503.54. Now let's understand previous month result. So if you look into the second visual, if I expand quarter 1, for the January month there is no previous month. So that's the reason for the entire January it is showing blank, and for the February month it is showing previous month sales 98,898.49. So if you look into for the February month, previous month would be January, and you can see the January sales is 98,898.49. So that's the reason for the February month it is showing previous month sales is 98,898.49. And if you talk about March, so for March previous month sales would be February month sales, and that would be 1,03,717.92. So if you scroll down, So here you can see the 1,03,717.92. Now understand the previous quarter results. So for the quarter 1 January to March, if you see here, it is showing blank. Again reason is the same. For the quarter 1 year 2012, there is no previous quarter sales, so that's the reason for the first quarter is showing blank. And in the second quarter, from April to June, it is showing 3,38,362.81. So for the second quarter, quarter 1 would be the previous quarter, and if you see the quarter 1 sales is 3,38,362.81. So that's the reason here it is showing the quarter 1 sales for the quarter 2. And again same, if you talk about quarter 3, so for the quarter 3, quarter 2 sales would be the previous quarter. So if you scroll down, so here you can see that for the quarter 3, July to September, it will show you the 4,80,132.84, which is quarter 2 sales, because for the quarter 3, quarter 2 would be the previous quarter. So that's the reason for the July to September, it will show you the quarter 2 sales. Now let's talk about previous year result. So it is showing the blank for the entire 2012 year. Reason behind, for the 2012 there is no previous year, so that's the reason for the year 2012 it is showing the blank. And if you talk about year 2013, so it is showing 22,59,450.90. So for the year 2013, what would be the previous year? So previous year would be 2012, and this is the 2012 year sales, 22,59,450.90. And if we talk about 2014, so for the 2014, previous year would be 2013, and it will show you the 2013 sales 26,77,438.69. So if you scroll down and go to the 2014, so here you can see the 26,77,438.69. So in same way, for the year 2015, previous year would be 2014, and it will show you the 2014 sales. So I hope you understand how previous day, previous month, previous quarter and previous year DAX function works. Now let's talk about another time intelligence DAX functions: start of month, start of quarter, start of year, end of month, end of quarter and end of year. First, let's understand their definitions. Start of month returns the first date of the month in the given columns of dates. Start of quarter returns the first date of the quarter in the given column of dates. Start of year returns the first date of the year in the given column of dates. And definition for the end of month, end of quarter and end of year is similar to start of month, start of quarter and start of year. The only difference between both, for the start of month, start of quarter and start of year, it will return the first date of the month, quarter and year in the given column of dates. And for the end of month, end of quarter and end of year, it will return the last date of the month, quarter and year in the given column of dates. Now let me show you the DAX measure for the same. So this is the DAX measure code for the start of month. So start of month is measure name equal to, here I use start of month DAX function, and inside that DAX function I pass the calendar date column name. So as per the definition, it will return the first date of the month in the given column of dates. Now this is the DAX measure code for the start of quarter. So if you notice here, everything is same. Here I only change the DAX function name start of quarter and then I pass the calendar date column name. And this is the DAX code for the start of year. Again I only change the DAX function name start of year and then I pass the calendar date column name. And this is the DAX code for the end of month. Everything is same. I only change the DAX function name end of month, then I pass the calendar date column name. This is the end of quarter DAX measure code. Here I only change the DAX function name, end of quarter, then I pass the calendar date column. And this is the last DAX code, end of year. I only change the DAX function name and then I pass the calendar date column name. Sometimes we need the start or end date of a month, quarter or year to perform certain calculation. In such cases, we can use these DAX functions. Now let me show you how these DAX function will work. First, I added one table visual in the report page, and after that I added date column from the calendar table, and after that I added all 6 measures here: a start of month, quarter, year, end of month, quarter and year. Now let's understand working of start of month. So here you can see the given date is 1st of January 2012, and as per the definition of start of month, it will return the first date of the month in the given columns of dates. So here date month is January, and in January first date would be 1st January 2012 because year is 2012. So that's the reason for the entire January month it will return the 1st January 2012. And here you can see the month has been changed. So now month is 2nd, means February. So for the entire February it will return the 1st February 2012 because as per the definition it will return the first date of the month in the given date columns. So I hope you understand how start of month works. Now let's understand the how start of quarter DAX function works. So here you can see the date is 1st January 2012, and as per the definition of start of quarter, it will return the first date of the quarter in the given column of dates. So you can see here for the first quarter means January, February and March. So it will return the first quarter date in the given column of dates. So for the first quarter, date is 1st January 2012. So that's the reason for the first quarter means January to March, it will return the 1st January 2012. And here you can see for the second quarter means April to June. So it will return the 1st April 2012 because for the second quarter, first date of quarter would be 1st April 2012 because year is 2012. So for the second quarter means April to June, it will return the 1st April 2012 date. So here you can see. And now third quarter has been started. So third quarter means July to September. So it will return the 1st July 2012 because for the third quarter, first date of the quarter would be 1st July 2012. So here you can see here for the entire third quarter it will return the same date. Now let's understand how start of year works. So for the 1st January 2012, first date of the year would be 1st January 2012. So that's the reason for the entire year 2012 it will return the 1st January 2012. So for the year 2013, you can see here first date is 1st January 2013. So that's the reason for the entire year 2013 it will return the 1st January 2013. Now let's understand the working of end of month, end of quarter and end of year. So for the end of month, here you can see the date is 1st January 2012, and as per the definition it will return the last date of the month in the given columns of dates. So here in the date column, month is January, and in January we have 31 days and last day would be 31. So that's the reason it will return 31st January 2012 for the entire January month. And now here you can see that month has been changed. So now we have February month, and here in the February month we have last date is 29th Feb. So that's the reason it will return the 29th February 2012 for the entire February month. So I hope you understand how end of month works. Now let's understand the working of end of quarter. So here you can see the date 1st January 2012. So here date month is January. January comes under first quarter, and in first quarter last month is March. So as per the definition of end of quarter, it will return the last date of the quarter in the given columns of dates. So here date is January. January comes under first quarter. In first quarter, last month would be March, and in March we have 31 days. So that's the reason it will return the 31st March 2012 for the entire quarter. And now here you can see that date has been changed. So now date is 1st April 2012. April comes under second quarter, and in second quarter last month is June. So as per the definition of end of quarter, it will return the last date of the quarter in the given columns of dates. So that's the reason for the 1st April 2012, it will return the last date of the quarter. April comes under second quarter, and in second quarter last month is June. In June we have 30 days. So that's the reason it will return the 30th June 2012 for the entire second quarter, means April to June. It will return the same date, 30th June 2012. So I hope you understand how end of quarter works. Now let's understand end of year working. So here you can see the year is 2012. So as per the definition, it will return the last date of the year in the given column of dates. So here date is 1st January 2012. So it will return the last date of the year in the given column of dates. So in the 2012, last day of the year would be 31st December 2012. So that's the reason for the entire 2012 year, it will return the same date, 31st December 2012. And here you can see that date has been changed. So now date is 1st January 2013. So for the year 2013, again it will return the last date of the year in the given columns of dates. So again date would be 31st December 2013 for the entire year 2013. So I hope you understand how start of month, quarter, year and end of month, quarter and year DAX function works. Now let's understand another time intelligence DAX functions, TOTALMTD, TOTALQTD and TOTALYTD. First understand their definitions. TOTALMTD calculates the total from the start of the month to the current date. TOTALQTD calculates the total from the start of the quarter to the current date. And TOTALYTD calculates the total from the start of the year to the current date. Here total can be any sales, values or amount, and we use TOTALMTD, TOTALQTD and TOTALYTD DAX functions to perform the time-based cumulative calculations such as month to date, quarter to date and year to date. We use these three DAX functions to calculate the cumulative sales, or we can say running total, at month to date level, quarter to date level and year to date level. Now let me show you the DAX code for the same. So this is the DAX measure for the TOTALMTD. Here I used TOTALMTD DAX function and it support two arguments. In first argument I used sum DAX function to calculate the sum of sales, and in second argument I passed the calendar date column name. This is the DAX code for the TOTALQTD. Everything is same, I only changed the DAX function name TOTALQTD. And this is the DAX code for the TOTALYTD. Here I only changed the DAX function name TOTALYTD. Now let me show you the relationship between orders and calendar table. So here you can see that in the orders table I used order date column, and in the calendar table I used date column to create the relationship between both tables. After that, in the report page I added three matrix visual, and in the first matrix visual, in the rows section I added calendar date column, and in the value section I added sales column and TOTALMTD measure. Why I added sales column? So that we can understand the working of TOTALMTD measure. In same way, in the second matrix visual, everything is same. Here only I am using total QTD measure. And in the third matrix, I just change the measure name and here I am using total YTD. Now let's understand the working of total MTD. You can see that for the 1st January, sum of sales is 808.56. Total MTD is also showing the same sale. Reason behind, before 1st of January 2012, there is no sales. So that's the reason it is showing the same sales. For the 2nd January, you can see that it is showing 1122.78, which is summation of 1st and 2nd January sales. For the 3rd January, it is showing 5626.32, which is summation of 1st, 2nd and 3rd January sales. For the 4th January, here you can see that it is showing 8435.19, which is summation of 1st, 2nd, 3rd and 4th January sales. So in same way, you can cross check the result of total MTD for the January month. It will return the cumulative sales, or we can say that running total for the January month. And for the next month, it will start the sales summation from the beginning, same like January month. You can see that for the 1st of January, it is showing the same sale. So in same way, for the 1st of February, it will show you the same sales. And for the 2nd February, it is showing the 10,168.35, which is summation of 1st and 2nd February sales. And for the 3rd of February, it is showing 10,534.99, which is summation of 1st, 2nd and 3rd February sales. So for an example, if you notice here, for the 29th Feb, it is showing 1,03,717.92 sales, which is summation of sales from 1st of Feb until 29th Feb. And for the March month again, it will start the summation from the beginning. So for the 1st of March, it is showing the same sales. And for the 2nd March, it is showing 13,628.31, which is summation of 1st and 2nd March. Now let's understand how total QTD works. It will work similar like total MTD. In total MTD, for the next month, it starts the summation from the beginning. So in same way, for the total QTD, for every quarter, it starts the summation from the beginning. So let's understand this. If you expand the January, February and March month, then you will notice it is returning the cumulative sales. For the 2nd January, you can see that it is showing 1122.78, which is summation of 1st and 2nd January sales. So in same way, if you notice 31st January sales, it is showing 98,898.49, which is summation of 1st of January until 31st January sales. And for the 1st of February, it is showing 1,01,354.16, which is summation of sales from 1st January until 1st of February. And for the 2nd February, it is showing 1,09,066.84, again which is summation of sales from 1st January until 2nd February. So in same way, it will cumulative the sales until March 31st. So for the March 31st, it is showing 3,38,362.81, which is summation of sales from 1st of January until 31st March 2012. And for the next quarter, which is April, May, June, so again it will start the summation from the beginning. So you can see that for the 2nd quarter, which is 1st of April, it is showing the same sale. And for the 2nd April, it is showing 9,801.31, which is summation of 1st and 2nd April. And in same way, from April, May and June, it will cumulative the sales. So if you scroll down and if you will check the sales for the 30th June, it is showing 4,80,132.84, which is summation of sales from 1st of April until 30th June 2012. And from July to September, which is 3rd quarter, so again it will start the summation from the beginning. And if you notice here, for the September 30th, it is showing 6,11,085.92, which is summation of sales from 1st July until 30th September. So for every quarter, it will start the summation of sales from the beginning. So in first quarter, we have January, February, March. So it will return the summation of sales from January to March, and for the second quarter means April to June, again it will start the summation from the beginning and then return the cumulative sales. So in same way it will work. Now let's understand working of total YTD DAX function. It is similar to total MTD and total QTD. The only difference, it calculates the total from the start of the year to the current date. So now let's understand this. So here you can see that in the year 2012 we have 12 months, and if you expand the December month, which is last month in the year 2012, and if you see the sales of 31st December 2012, so here you can see the total YTD showing 22,59,450.90, which is summation of sales from 1st January 2012 until 31st December 2012. So it will sum up the sales from 1st of January until 31st December 2012 for the entire year. And for the next year 2013, if you expand the January, so again it will start the summation from the beginning. So you can see that for the 1st of January, it is showing the same sales, which is 10,006.66, and for the 2nd January 2013, it is showing 13,459.97, which is summation of 1st and 2nd January. In same way, if you expand the December month in the 2013 and check the last date of the December 31st, so here you can see that it is showing 26,77,438.69, which is the summation of sales from 1st January 2013 until 31st December 2013. So for the entire year 2013, it will return the cumulative sales. And in same way for the year 2014, again it will start the summation of the sales from the beginning. So I hope you got some clarity how total MTD, total QTD and total YTD works. Total MTD will return the cumulative sales for the month, and for the next month again it will start the summation from the beginning. Total YTD will return the cumulative sales at quarter level, and for the next quarter again it will start the summation from the beginning. In same way, total YTD will return the cumulative result or cumulative sales for the year, and for the next year again it will start the summation from the beginning. Now let's understand another time intelligence DAX functions, DATESMTD, DATESQTD and DATESYTD. First, understand their definitions. These functions return a table of dates from the start of the month, quarter or year up to the current date in the filter context. And also these functions help us to calculate the cumulative total, or we can say running total, at month to date, quarter to date and year to date level. Same like total MTD, total QTD and total YTD. I will also explain to you the difference between both. Now let me show you the DAX code for the DATESMTD, QTD and YTD. This is the DAX measure code for the DATESMTD. Here I used calculate DAX function, and inside it I passed two arguments. In the first argument I used some DAX function to calculate the total sales from the orders dataset, and in the second argument I used DATESMTD DAX function, and inside it I passed the calendar date. Here DATESMTD returns a table of dates from the first day of the current month up to the current date in the context, like in a visual or report. And calculate DAX function modifies the default filter context and re-evaluates the sum only for the dates returned by DATESMTD. And the biggest advantage of calculate DAX function is it allows us to apply custom filter or logic or perform advanced calculations. So here you can see the another example of DATESMTD. Here everything is same. The only change is here in the DATESMTD DAX function. I passed two arguments. In first argument you can see the calendar date column, and in the second argument I added one condition, category equal to furniture. This DAX code will return the cumulative sales only for the category furniture. Now let me show you the DAX code for the DATESQTD. Here you can see that everything is same. Here I only change the DAX function name DATESQTD. Here DATESQTD returns a table of dates from the first day of the current quarter up to the current date in the filter context. Now let me show you the DAX code for the DATESYTD. So here you can see that again everything is same. I only change the DAX function name DATESYTD, and here DATESYTD returns a date range starting from the beginning of the current year up to the current date. And this is the another example of DATESYTD. You can see here inside of DATESYTD I pass two arguments. In the first argument you can see the calendar date, and in the second argument I pass the physical year June 30. So this condition creates July 1st as the start of the year. So later on I will show you the working of this DAX code. Before moving further, one important point to remember: if you are working with DATESMTD, DATESQTD and DATESYTD DAX functions, make sure you are using calendar table. This is because the calendar table contains dates in a continuous sequence and there is no chance of missing any dates. That's why I used calendar date column inside the DATESMTD, DATESQTD and DATESYTD DAX functions. I also created a relationship between main data set and the calendar table, and I am using the calendar date in both DAX function and report visuals. Now let's understand the working of DATESMTD. So here you can see the for the 1st of January actual sales is 808.56 and DATESMTD is also returning the same sales 808.56 because before 1st of January 2012 there is no sales, so that's the reason it is showing the same sales 808.56. And for the 2nd January you can see here it is showing the sales 1122.78. This is the sales summation of 1st of January and 2nd of January. For the 3rd of January you can see here it is showing the sales 5626.32, which is summation of sales from 1st of January to 3rd of January. So in same way you can cross check the result of DATESMTD for the January month, and from the next month it will start the summation from the beginning. So you can see here for the 1st of February it is showing the same sales, and for the 2nd February it is showing 10,168.35, which is summation of 1st and 2nd February sales, and for the 3rd February it is showing 10,534.99, which is summation of 1st of February to 3rd of February sales. So this is the cumulative sales for the February month, and if you notice here for the 29th February it is showing 1,03,717.92, which is summation of sales from 1st of February to 29th February. So this is the cumulative total, or we can say running total sales for the February month, and for the next month again it will start the summation from the beginning. So you can see here for the 1st of March it is showing the same sales, and for the 2nd March it is showing 13,628.31, which is summation of sales for the 1st and 2nd March. So in same way you can cross check the result for the DATESMTD. Now let me show you how you can add filter condition with DATESMTD. So here you can see that this is the current condition, and this condition will return the cumulative total for the month to date level. Now we will comment this current condition and will enable the second condition, which is filter condition. You can see here, and if you notice here everything is same. The only change is here inside of DATESMTD I passed one extra argument, you can see here, and this is the filter condition. So here DAX code is DATESMTD, and after that I added calendar date column, and in the second argument I pass the filter condition where category equal to furniture. So this DAX code will return the cumulative sales at the month to date level only for the category furniture. Now let's click on comment, and here you can see here, so earlier actual sales was 808, so now sales is 113.67, means it is showing only the sales for the furniture category for the 1st January. And for the 2nd January, if you see here, it is showing the same sales. So might be there is a chance for the 2nd January we don't have any category sales, so it will consider that sales as a 0, and then it will add 1st January sales with 2nd January sales and then return the result. So for the 1st January sales we have 113.67, and 2nd January we don't have any sale, so 113.67 plus 0 equal to 113.67. So in same way it will return the cumulative sales for the category furniture. And for the next month again it will start the summation from the beginning. So you can see here, for the 1st February it is showing 600, then for the 2nd February 3709.20. so this is the summation of sales for the category furniture. So this time don't compare the sales with DATESMTD result. Reason behind this is the actual sales with all categories, and DATESMTD is returning the sales only for the furniture category. So I hope you understand how you can implement the filter inside of the DATESMTD DAX function. Now let's understand the working of DATESQTD. It will work similar to DATESMTD but at quarter to date level. Now let me enable the date hierarchy for the date slicer. So just select the slicer, right click on the date column and select date hierarchy. Now you can see here we have year, quarter and month and day level data. So with this date hierarchy you can easily understand the working of DATESQTD. So if you notice here, in quarter 1 we have 3 months, January, February, March. And now let's check the data. For the 1st of February you can see here sales is 808.56 and DATESQTD also showing the same sales. The reason behind, before 1st of January 2012 we don't have any sales, so that's the reason it is showing the same sale. For the 2nd January sales is 314.22 and here it is showing 1122.78, which is the summation of 1st and 2nd January sales. So in same way DATESQTD will return the cumulative sales until 1st quarter. So 1st quarter means January to March. So if you notice here, in the March sales is 2582.80 and here it is showing 3,38,362.81, which is the summation of sales from 1st January to 31st March 2012, because in the 1st quarter we have 3 months, January, February, March, and here we are using DATESQTD, so it will work quarter to date level. So for the 2nd quarter, which starts from April to June, it will start the sales summation from the beginning. So if you see here, for the 1st of April sales is 8,922.05 and DATESQTD showing the same sales. The reason behind, for the next quarter it will start the sales summation from the beginning and then it will show you the cumulative sales for the 2nd quarter, means until June. So if you expand the June, so here you can see here, for the 30th June it is showing 4,80,132.84, which is the sales summation from 1st of April to 30th June sales. And again for the next quarter, which is July, August and September, so it will start the sales summation from the beginning. So you can see here, for the 1st of July we have 388.96 sales, that is showing the same, and for the 2nd July we don't have any sales, so it will consider 0. So 388.96 plus 0 equal to 388.96, and in same way it will show you the cumulative sales from July to September. If you expand the September, so here you can see the cumulative sales until 30th September 2012. Now let's understand working of DATESYTD. it will return the cumulative sales for the year to date level. So if you notice here, for the year 2012, we have 12 months, January to December, and if you expand the December month and check the sales for 31st December, so here you can see the dates YTD showing 22 lakh 59,450.90, which is sales summation from January 1st 2012 to 31st December 2012. And for the next year, it will start the sales summation from the beginning. If you expand the January 2013, you can see here for the 1st January sales is 10,006.66. So dates YTD is showing the same sale, because for every year it will start the sales summation from the beginning. And if you expand the December month, so here you can see the sales for the 31st December, it is showing 26 lakh 77,438.69, which is sales summation from 1st January 2013 to December 31st 2013. So here you can see the entire year 2013 cumulative sales, and you know very well how cumulative sales work. So for the 1st of January, it will show you the same sale. For the 2nd January, it will show you the sales summation of 1st and 2nd January. And for the 3rd January, it will show you the sales summation of 1st, 2nd and 3rd January. So cumulative work like that. Now let me show you how you can pass the physical month inside of dates YTD DAX function. So this is the current code for the dates YTD, calculate sum of sales, dates YTD and calendar date. Now I am going to comment existing code, and here I enable the another DAX code with physical month condition. So if you notice here, everything is same, calculate sum of sales, dates YTD. The only change here, now inside of dates YTD I pass two argument. First argument is same like earlier, calendar date, and in the second argument I pass the physical month, June 30. So 06 means June and 30 is day. It will tell Power BI this is the end of the physical year, means June 30 is end of the physical year, and this treats July 1st as the start of the year. So I hope you understand mean of this condition. So here I passed June 30. So it will consider June 30 is the end of the physical year and July 1st is the start of the year. Now click on commit, and now let's see the change here. So if you scroll down and expand the June month, so here you will notice the cumulative sales, and if you check the sales for the 30th June, it is showing 8 lakh 18,495.65, which is the sales summation from 1st of January 2012 until 30th June 2012. And if you expand the July month, so here you can see that, so as per our condition, it will consider June 30th is end of the physical year, and it will create July 1st is the beginning of the year. So you can see here for the 1st of July it is showing the same sales, which means it will start the sales summation from the beginning, and it is considering July 1st is the start of the physical year, and again it will return you the cumulative sales. So I hope you understand how you can pass the physical month inside of dates YTD. Now let's understand the difference between total MTD, total QTD, total YTD and dates MTD, dates QTD and dates YTD. These all functions you can use to calculate the cumulative totals, or we can say running total. Then what are the main difference between all? So here you can see the, if you talk about return type, total MTD, QTD and YTD returns a scalar value, example number, and dates MTD, QTD and YTD returns a table of dates. And you can use directly total MTD, total QTD and total YTD DAX function to calculate the cumulative totals. So let me show you the DAX code for the total MTD. So here you can see that syntax for the total MTD, QTD and YTD is straightforward. Inside of total MTD, you just pass the sum of sales and calendar date, and you will get the cumulative sales. And if you talk about dates MTD, dates QTD and dates YTD, so inside of calculate DAX function, you can use the dates MTD, dates QTD and dates YTD, and you can define the filter conditions and physical calendar. So this is the advantage of dates MTD, QTD and YTD, because you can define these functions inside of the calculate DAX function, so that you can apply the custom filters and you can define the physical calendar. Now let's talk about the flexibility. So total MTD, QTD and YTD is less flexible for applying extra filter, and dates MTD, dates QTD and dates YTD is more flexible. You can assign the custom filters or physical calendar. So you can see here. Another difference is customization. So with total MTD, QTD and YTD, you have limited control to define the physical year. It needs extra parameter. And with dates MTD, QTD and YTD, you can easy to customize physical calendar and filters, which I already showed to you. So you can see here. So here you can easily define the filters and physical year. And last one is easy to use. So total MTD, QTD and YTD is easy to use, and dates MTD, QTD and YTD is slightly more advanced but powerful. I hope you understand the difference between total MTD, QTD, YTD and dates MTD, QTD and YTD, how they are different and when to use each one. Now let's understand another time intelligence DAX function, same period last year. This is a definition. This function returns a table that contains a column of dates from the same period in the previous year based on the dates provided. And this is a use case of same period last year DAX function. Sometimes we need to compare current performance with the same period last year. Now let me show you the DAX code for the same period last year. So this is the DAX code. Here I used calculate, and inside calculate you can see the two arguments. In first argument I used sum function to calculate the total sales, and in the second argument I used same period last year DAX function, and then I passed the calendar date column name. Let's understand the working of same period last year. So if you notice here, for the year 2012, it is showing blank sales for the same period last year. Reason behind, for the year 2012, there is no previous year sales. So that's the reason for the entire 2012, it is showing blank. And if you expand the 2013 year and check the sales for January 1st, 2013, so the actual sales is 10,006.66. And here you can see the same period last year sales 808.56. So this is the sales of same period last year. And if you check the same period last year sales means 1st January 2012. So here you can see the sales is 808.56. And now again check the 2nd January sale. So the actual sales is 3,453.30. And here you can see the same period last year sale 314.22. So you can check the sales for the year 2012 2nd January 314.22. Same you can check for the 11th January 2013 sale. Actual sales is 8,385.10. And here you can see the same period last year sale is 6,451.25. Now let's check the sales for the January 11, 2012. So here you can see the sales 6,451.25. So I hope you understand how same period last year DAX works. Now let's understand another time intelligence DAX function, parallel period. This is a definition for the parallel period. Parallel period is a DAX function used to get data from a previous or next time period like last year, last month or last quarter based on a date column. Now let me show you the DAX code for the parallel period. Here you can see that I used calculate DAX function, and inside calculate DAX function you can see the two arguments. In first argument, I used some DAX function to calculate the total sales, and in the second argument, I used parallel period DAX function, and inside parallel period DAX function, you can see the three argument. In first argument, you can see the calendar date. In the second argument, I pass the number of interval, and in the last argument, I pass the interval name. Interval name can be 3, month, quarter, and year. So right now, I just pass the year interval, and instead of 1, right now I just pass the -1, and after that click on commit. So this DAX code will return the previous year sales against the current year. So now let's understand this. If you notice here, for the entire year 2012, it is showing the blank sales. Reason behind, here current year is 2012, so it will subtract -1 from the current year and it will return 2011 sales. And in our data set, we don't have any 2011 sales. So that's the reason for the entire year 2012, it is showing the blank sale. Now let's check the same for the year 2013. So you can see here, in the year 2013, it is showing 22,59,450.90. So which is previous year sales 2012. You can see here 22,59,450.90. Because here current year is 2013. So from the current year it will subtract -1 and then it will return the 2012 year sales against entire year 2013. So you can see here, for the entire year 2013, it is showing the previous year 2012 sales, and same for the year 2014, it will return the 2013 year sales. It is showing 26,77,438.69, which is previous year 2013 sale. And instead of year interval, if we change it to month, so let's see what happens. Click on commit. So now you can see here, for the January, it is showing blank, because before January 2012 we don't have any sale, that's why it is showing blank. For the February, it is showing January sales because we subtract 1 month. So in the February month, it will show you the previous month sale, which is 98,898.49. so here you can see the January sale. For the March, it will show you the February month sale. So here you can see it is showing 1,03,717.92, which is February month sale. And what will happen if we will change the interval from -1 to 1, and now click on commit. So now you can see here, for the January month, it is showing 1,03,717.92, which is next month sale. So here you can see the February sale, because here interval is in positive +1. So for the March, it will show you the April sale. So here you can see that it is showing 1,14,332.96, which is next month April sale. Here you can see. If you will change month to quarter, and instead of 1, just past -1. So let's see what happens. So you can see here, for the first quarter, Jan to March, it is showing blank, because before this quarter we don't have any sale. For the second quarter, April to June, it is showing the sales of previous quarter, which is sales summation of January to March, 3,38,362.81. So you can see here, for the entire second quarter, it is showing the same sale. If you expand any month in the quarter 2, so it will show you the same sale, 3,38,362.81. And for the quarter 3, July to September, it will show you the sales summation of quarter 2, which is 4,80,132.84. So you can see here, for the entire quarter 3, it will show you the sales of quarter 2. I hope you understand how parallel period works with interval and interval name. Now let's understand another time intelligence DAX functions, date at, dates between, and dates in period. First, start from date at. Date at shifts a set of dates forward or backward by a specified number of intervals such as days, months, quarters or years. Let me show you the DAX code for the date at DAX function. So this is the DAX code for the date at measure. So here I use calculate, and inside calculate you can see the two argument. In first argument I pass the sum of sales, and in second argument I use date at DAX function, and inside it you can see the three argument. In first argument you can see the calendar date column name. In the second argument I pass the number of interval -1, and in third argument I mention the interval name. So here you can pass four level of intervals: day, month, quarter or year. So right now I am using day, and after that click on commit. So here you can see the result of date at DAX function. So for the 1st January it is showing blank because here we are subtracting one day from the current date. So let's suppose if current date is 1st of January, so before 1st of January there is no sale, so that's the reason it is showing blank. For the 2nd January it will subtract one day from the current date. So current date is 2nd January, 2nd January -1, so it will return the 1st January sale, which is 808.56. In same way for the 3rd of January it will show you the 2nd January sale, which is 314.22. You can see here. In same way you can cross check the result for the date at. Now what will happen if we will change the interval from -1 to 1. Now you can see the result. For the 1st of January it is showing next day sale 314.22, which is 2nd January sale. You can see here. In same way for the 2nd January it is showing 3rd January sale, because here we are adding one day in the current date. In same way, instead of day, if you will pass month, and let's see what happens. So now you can see here month is January and we added 1 in the current month, means in the January it will return the February month sales. So if you see here for the 1st of January it is showing 2455.67. So let's check the sales for the February 1st. So here you can see sales for the February 1st 2455.67. And if you see the 2nd January sale, it is showing 7712.68, which is February month 2nd January sale. So you can see here 7712.68. Now let's understand dates between DAX function. Dates between returns a table with all dates between a start and end date including both. If you want to filter data between two specific dates, then you can use the dates between DAX function. Now let me explain you this DAX code in the detail. So here I want to calculate last 30 days sales. So for that I used calculate DAX function. Inside calculate DAX function I used sum DAX function to calculate the total sales as in first argument. And in the second argument I used dates between DAX function. And inside it, in the first argument I pass the date column name, which is calendar date, and in the second argument, which is start date, so here I define the manual date 1st November 2015. If you are defining manual date, so for that you have to add date function first, and inside the date function you have to follow this format. First you have to define year, then month, and then day with comma separated. And after that in the end date I define manual date 31st December 2015 in the same format. You can see here first I add date function, and inside it I define the year first, then month, and then day, and after that click on commit. So this DAX code will return the last 30 days sales. So here I define November and December month. So how we will cross check the result? So for that first I added one card visual in the report page, and in the card visual I added my dates between measure, and in the slicer we will select 2 months November and December. You can see here, and in the matrix visual you can see the sum of sales for the November and December month is 10,58,422.72, which is exactly matching with our dates between DAX result. So I hope you understand how you can use date between DAX function to filter the data or to calculate the data between two specific date. And instead of manual date, you can also provide the dynamic date like this: min date from the calendar date and max date from the calendar date. So what will happen? So min calendar date DAX code will return the minimum date from the calendar table date column, and max calendar date DAX code will return the maximum calendar date from the calendar table, and based on that it will return the total sales. After that, click on commit, and here you can see the result as per our specified start and end date. So there is a lot of ways to define the start and end date inside the dates between DAX function, such as manual and dynamic date. So I hope you got clarity how dates between DAX function works. Now let's understand another DAX function, dates in period. Dates in period DAX function returns a continuous range of dates from a starting date over a specified number of intervals like days, months, quarters, or years. It is commonly used when you want to calculate values for a moving time period. For example, last 7 days, last 3 months, or last 1 year. Now I will explain you this DAX code in details. Here I want to calculate last 6 months sales based on some time period intervals, which you can see here. And after that I click on commit. Now let's understand the DAX code. So here I used calculate DAX function, which is used to modify the filter context and perform a calculation. And after that I used some DAX function to calculate the total sales as in first argument. And in the second argument I used dates in period DAX function with few parameters. So you can see here in the first parameter, which is date. So here I passed calendar date column. Second parameter is start date. So to get the start date I used max DAX function, and max DAX function will check the max date in the calendar table calendar date column, and then it will return the max date here. And in the third parameter, which is interval number, so here I passed -6, and in the last parameter, which is interval name, so here I passed month. After that click on commit, and in the report page I added one card visual to see the result of dates in period, and after that I drag that measure here, and it is showing 26,77,672.22. So now let's understand why it is returning this sales. So let me show you the DAX code once again. So in the start date parameter, we are using DAX code max calendar date. So it will check the max date in our calendar date column. So let's check the max date in our calendar table. So this is a slicer, and here I am using calendar date column. And if you expand the year 2015 and expand the month December, here you can see that we have max date is 31st December 2015. So in our data set, max date is 31st December 2015. And now let's understand working of dates in period. So here you can see that max calendar date will return 31st December 2015, and after that in our DAX code we used -6 interval, and interval name is month. So here -6 and month means it will go 6 months back from 31st December 2015. So date range would be 1st July 2015 to 31st December 2015. So here dates in period will return the dates from 1st July 2015 to 31st December, and based on that date range it will calculate the total sales. So I hope you understand how dates in period works. And now let's cross check the sales for the dates in period. So it is showing 26,77,672.22. Now put the filter from July 1st to December 31st and check the sales. In the matrix visual, For the 6 month from July to December, it is showing total sales 26 lakh 77,672.22, which is exactly matching with our dates in period result. Now let's change the condition. So here I am changing -6 with 3 and click on commit. So now it is showing 14,81,189.35. So let's check this. So now max date is 31st December 2015, which I showed you earlier, and from that date it will go back 3 months. So now change the filter. So December is 1st, November is 2nd, and October is 3rd. And now you can see the sales in matrix visual. It is showing 14,81,189.35, which is exactly matching with our dates in period result. And here you can also change the interval name month to day, and let me change here interval number from -3 to +2, and let's see the result. So now it is showing 13,257.95. So let's check this, why it is showing this sales. So let me clear the result of slicer. So here we have max date is 31st December 2015, and here interval 2 and interval name day means it will go forward 2 days from the max date. But here catch is we have max date is 31st December, and after that we don't have any data in our data set. So that's the reason it is only returning the 31st December sales. And what will happen if we change the interval from 2 to -2? So let's see the result. So now it will go back 2 days from the max date, which is 31st December 2015. So it will show you the 2 day sales, means 30 and 31st December 2015. So let me put filter here in the December month, and let me select the 30 and 31st day, and here you can see that sales of 2 days 30,089.57, which is exactly matching with our dates in period result. So I hope you understand how dates in period works. That's all for this video. We covered all time intelligence DAX functions. If you like the video, please like, share and comment. It really helps motivate me to create more videos. Thank you.